Hey Internet, welcome to Thermodynamics tutorial. This is a made-up question not found in your textbooks. So we're going to use the previous question using software to create a table and a graph. The graph is power on the y-axis versus velocity on the x-axis, and we're going to vary the velocity, and we're going to vary the diameter of the wind blades from tip to tip as well. So for viewers that haven't done the previous question, here is the previous question. You can pause the video and solve it yourself if you wish. I have done it previously, so you can just pause the video if you want to and go through the steps. I won't be explaining how each step works. You can watch that video. Okay. Note that the pinned comment will have the Python code for the graph and table. I will also provide the original EES code. However, due to copyright, I can't show you that. But that's okay, you can just read the pinned comment. Okay, so here is the graph. It's probably better if I just open up Python, just because it's actually cut off. So there's a scroll button on Python, or in this case using Visual Studio. So let me just open up the graph and table. Okay, so now that it's in full screen, we can discuss the results. So let me just scroll down to the missing bit. So it was cut off here, I believe. So it started at 100 and it cut off. So you can pause the video and take a screenshot from 100 to 120. Okay. So let's discuss the graph, and then we can come back to the Word document. So each line represents the diameter from blade tip to blade tip. If you are colorblind, apologies. So the very bottom line is the lowest diameter, and the highest line is the highest diameter. So we've got 20, 40, 60, 80, 100, and then 120 meters in diameter for the blade tip from one end to the other. So what you're seeing is an exponential curve, as you can see. And as you can see, the faster the wind speed is, the more power the turbine will generate. So that's what this graph is indicating. So that's the main, I guess, results. Now, another observation in this graph is that the larger the diameter of the turbine from tip to tip of each blade, you'll generate more power. So having a smaller diameter turbine will generate less power. When you have a larger diameter turbine, then you will generate more power. Now, as you can see, it doesn't escalate until we reach around about 7 to 8 meters per second. So from 7 and below, the power generation is near 0. So as you can see, 6 is when it starts generating some power, and then 7 onwards is it, as you can see, it diverges and starts actually generating more power. Okay, so let us come back to the Word document. So the main conclusion is that it is dependent on the wind speed for power generation, and it is the cube of the wind speed. So the faster your wind speed and the larger the diameter of your blade tips, the more power you will be able to generate. So disclaimers, I do make calculation mistakes. I encourage you to solve it yourself and see if you get the same answer. Now, before we leave, I highly encourage you to save this video onto your PC just in case this video or channel gets taken down. While I follow all copyright laws, sometimes things just happen. You can do this by using snipping tool. If you never used snipping tool before, follow the instructions below. If you're on a Mac, use the Mac equivalent of snipping tool. So go to your taskbar, click on the icon, open up the program. If it's not in your taskbar, go to your Windows search, type in snipping tool. Okay, once you have it open, click on video option and then click on new. Left click and drag the rectangle to cover the YouTube screen. This is just an example. Then hit the start button on snipping tool, wait for the countdown, hit the replay button on YouTube, let the video finish. Hit the red square in snipping tool to stop recording and then save your video. So thanks for watching. Like and subscribe. If you got questions, comments, or if you find a mistake in this video, leave it in the comment section. I will get back to you as soon as possible. If you want to support me, become a member or drop a super thanks. Until next time, see ya.